In college algebra, we moved on to chapter 6 about matrices. And that's where, in this situation, you take a system of equations, like we see right here. You get rid of all the letters, and you rewrite it in this form right here. So take a minute, make sure you see how we go from that top system at the top of the page to that augmented matrix. The vertical line that's drawn right there, that's not super important. I honestly don't write it. You're supposed to write it, but I typically don't write that. What is crucial is that you have a number representing each spot. So, for example, if maybe there wasn't an X in a spot, you would need to write a 0. So every spot needs to have a number. And that's step 1. Step 2 is kind of weird. This guy Gauss, he created this process where you change that matrix that we just wrote into row echelon form. So to be in row echelon form means that we get ones on the diagonal and zeros in the bottom left corner. These numbers we don't care about. They can become anything. So they could be ugly fractions, they could be ones, they could be zeros, they could be something else, we don't really care. But the ones and those zeros have to become ones and zeros. Notice right now we have a 3, 1, 2 and 1, 1, 3. We need to change all of those to what you see on the very bottom of the screen. So, let's scroll down. On the left, just because I need the space, I'm going to write what we want it to look like. And all the other numbers we don't really care about. That's a funny looking 0. There we go. So what we want to do is we want to use things that we did last chapter when we did elimination to make numbers either cancel out or change into zeros and ones. One of the easiest tactics, maneuvers, I don't know what you want to call it, is to literally flip a row with another row. Now, when we go about doing this, you need to be really careful. I would only go one column at a time. And you want to move left to right. Top to bottom. So there are probably other ways to approach this. I don't want to limit you, but yet if you don't go in an organized way, you can make a mess of things, because this thing is like a Rubik's Cube. So that means I am only going to deal with this column to start out with. Just be aware when I change any of those 3 numbers, the other numbers may change as well. I just don't care what they change to. So my eyes are only on those 3 numbers. And like I was just saying, one really easy way to approach something, if you maybe need a 1, is to flip a row. So what if we flip row 1 and 2? Look at row 2. It starts with a 1, so if I literally flip the row, you can do this anytime you want, we create a 1 right here, which is what we need right here. So that means I need to write what was printed on row 1 now on row 2. So let's copy that. We got a 3, 1, 2. 31, and a 1, 3, 2, 25. So we got one of the 6 numbers dealt with. Now be aware, sometimes numbers change that are where we want them right now. So for example, this 1 in just a second might change, and we're not worried about that. Because all I'm worried about in this moment right now are these 2 numbers. So I'm going to move down and to the left, and I'm going to write what I'm about to do. So I'm going to copy row 1, because row 1 is done. And I want that 3 to become a 0. So what if I multiply row 1 by -3 and add it to row 2? This was what Gauss discovered, was that you can manipulate a row, add it to a row, and get a new row, but yet the weird thing is it doesn't affect the row you manipulated in the first place. So I'm taking row 1 and I'm multiplying by 3. So if it helps, I'm going like this. 3. Oh, sorry, I need a -3. -3, -3, -3 times all 4 of those numbers, and I'm adding it to row 2. So I end up getting 0, which was the reason for all of this. -3 times 1 is -3, plus a 1 is -2. -6 plus 2. And this one I type into the calculator. You can type any of these into the calculator. So we go -3 times 19 plus 31, and we get -26. How can I make this 1 become a 0? Well, look at the top row. I have a 1 up there. Ignore the red writing, by the way. I have a 1 up there. What if I was to go row 3 minus row 1? If I go row 3 minus row 1, I get a 0 right there. I get a 2. I get a 0. And a 6. If you need to pause it and double check, the rule that I applied is on the left, and I applied that rule to the previous matrix that I had. So now I'm going to move right. I'm done with column 1, and I'm done with row 1. So I'm going to copy row 1. Now row 2. I see a -2 right here. I need that to become a 1. So I know if I was to multiply -1/2 times -2, I would get a 1. So let's do that. We have to multiply -1/2 times every number on that row, and we get 0, 1, 2, and 13. I need this 2 to become a 0. So what if I combine row 2 and row 3? Whoops. If I do that, I get a 0. I get a 0, which is what I was hoping to achieve, a -4, and a -20. And now we're almost done. I got to make this into a 1, and we're ready to go. So I'm going to copy row 1 and row 2. And I'm going to multiply by -1/4 so that that -4 becomes a 1. So I stick with 0 and 0, and I get a 1. And conveniently, I get a nice number right there, 5. All right, if you made it that far, we're about done. Now you reattach the letters. Remember when we made the augmented matrix here? We dropped the letters. You reattach the letters. So that means x plus y plus 2z equals 19. Y plus 2z equals 13. And z equals 5. Look at that. We have one of our answers. And then I can use back substitution, plug in 5, and I can get y. Y is 3. And then I can plug z and y into that first equation and get z. So I know that, which means x is 6. All right, that was all we did on Monday. I will see y'all later. Bye.